Hi everybody, here we're gonna make a battery using these materials: a lemon, a galvanized nail, and a penny. So in the end, after we make this battery and combine it with a few others, we will make an LED light flash up. So to make the battery, what you need is to put the galvanized inside the lemon, inside this hole. It's a pre-made hole. And to put the penny inside this other pre-made hole. So now you have a battery, or in other words, an electrochemical cell. An electrochemical cell is used to produce or use electricity. In the electrochemical cell, we have electrodes, which are the penny and the nail. Electrodes are electrons that enter or exit electrochemical cells. In this scenario, the penny and nail are electrodes. The penny is a cathode, which means it has a positive charge, and the nail is an anode, which means it has a negative charge. Alessandro Volta discovered that any two metals in any electrolyte could be used to produce electricity. The two metals in this case are copper and zinc. And the electrolyte is the lemon juice. In order to show that this electrochemical cell has cell potential or voltage, which I will explain in a bit, we must use this voltmeter to show that. So you need to connect the negative hand to the anode, or the negative charge, and the positive hand to the cathode, or positive charge. So you turn the voltmeter on, and so now you see this. And the charge of this is 0.373, which is pretty low voltage. But when you combine it with other lemons or other electrochemical cells, it will be quite higher, and it will be able to light up an LED light. Before I explain to you guys about this circuit we've got here, I'm going to tell you a bit more about electrochemical cells. So there are two types of electrochemical cells. There are voltaic cells and electrolytic cells. These right here are voltaic cells, which means that they produce electricity. So in voltaic cells, the ability to transfer electrons from one electrode to another in the cell, or in other cells, is called cell potential. And cell potential is measured in units of volts, like I showed you before. So now, since we have all these electrochemical cells, or voltaic cells, whichever you'd like to call them, when they're combined together, they have a larger volt. And now it might be enough to light up this LED light we've got here. Now we're going to be measuring the voltage of this circuit right here, or the cell potential of it. But this time, because it's a lot more electrochemical cells joined together, the circuit will be a lot higher. The voltage of the circuit will be a lot higher. So now you can see the voltage is 3.42, a lot higher, and this might be able to light up this LED light we've got here. When you connect the electrochemical cell to the LED light, it turns out to work because there's enough voltage to light it up. Like shown here, the electrons flow from the anode to cathode like the rest of the electrochemical cell circuit.